Welcome to this video on the Bar Pendulum experiment, focusing on the determination of the acceleration due to gravity d. The key formula we will explore is G equals 4 pi squared, LD/t squared. Let's test your knowledge with a quick quiz. The bar pendulum is a classic example of a compound pendulum. The formula for the time period t is t equals 2 pi square root, I mgl. 4 distinct intersection points on the t versus distance graph yield the same period. The center of suspension and oscillation are interchangeable, meaning the time period remains the same if the pendulum is suspended from the oscillation point. The equivalent length L is given by L equals L plus k squared / L. The minimum period t occurs when the suspension distance L equals the radius of gyration k. The theoretical formula for minimum time period is Tmin equals 2 pi square root, 2k per gram. The primary objective of this experiment is to find the acceleration due to gravity, g. Moving from the center of gravity, cg, to the ends, the time period drops to a minimum and then rises again. If suspended at the CGL equals 0, the time period is infinity because there is no restoring torque. The graph of t versus L forms two asymptotic curves. The equivalent length L from the t versus L graph is the distance between asymmetrical points with the same time period. To calculate the radius of gyration k using the t versus L graph, if the distance between minimum points is d, then k is d/2. The derivation of the formula strictly uses the small angle approximation. The time period is entirely independent of the total mass of the bar. A bar pendulum is a rigid metallic rod with holes at regular intervals, acting as a compound pendulum when suspended on a knife edge. A compound pendulum is any rigid body free to oscillate about a fixed horizontal axis under gravity. The centers of motion are the point of suspension and the center of oscillation. The principle of reversibility states that the center of suspension and oscillation are interchangeable, maintaining an identical period. Holes are placed symmetrically to plot a complete t versus L graph and find interchangeable points. The distance between minimum point tangents on the graph represents twice the radius of gyration, 2k. The time period approaches infinity at the CG because the suspension distance is 0 and no restoring torque exists. The equivalent length L is the length of an idealized simple pendulum with the same period, defined as L equals L plus k squared / L. The time period depends on L, k, and g, but not the bar's total mass. The oscillation amplitude must be kept small, less than 10 degrees, to ensure the small angle approximation holds, fulfilling the condition for simple harmonic motion. The 4 intersection points on a horizontal line of the t versus L graph represent 4 interchangeable positions with the same time period. Acceleration due to gravity g is calculated using the formula g equals 4 pi squared, L/t squared. Here are the key formulas. Time period of oscillation, t equals 2 pi square root, I/mgl. Equivalent length, L equals L plus k squared / L. Acceleration due to gravity, g equals 4 pi squared, L/t squared. Minimum time period, Tmin, equals 2 pi square root, 2k per gram, occurring when L equals k. Thank you for watching this video. If you found this content helpful, please like, share, and subscribe to support our science content and never miss a lecture.